Hello, scientists. Mr. Miller again. We're finishing or coming to close to the end of our discussion of the water cycle. And we talk about the movement of water across surfaces or water through the entire water cycle from the atmosphere to the ground and then back into the atmosphere, back into the ground. This whole process is a renewing cycle. That means that when you evaporate water, no matter what it has in it, whether it has salt or man made pollutants, once you evaporate it, only the water vapor is turned into a gas. All the solids, all the bacteria, all the other stuff is left in the water so that when it falls from the sky as either snow or rain, then that's pure water. That water, you can't tell any difference from any other pure water. You can't tell where it came from because it could have came from anywhere. So during the water cycle, two things are transported or move through the cycle. The first one is energy. And we said ultimately the sun produces the energy that causes molecules of water to gain enough energy that they can leave the liquid state and scatter into the atmosphere to form clouds, and we call that evaporation. And then as that heat is lost to the surrounding atmosphere, water molecules combine or condense and fall back down. The water itself are basically matter. And everything in the water, the solids, the dissolved salts, the gases in the water, those are all matter. Okay, so both of those things are flowing through those systems. Now, one of the problems with surface water, most surface water in the world is not safe to drink because as it crosses the ground, if there's any bad stuff in the ground or around that gets picked up by the water, because water is a solvent, that means a lot of things mix in water, then it will pick up those bad things and hold it in the water all the way down, from the tributaries all the way down to the ocean. And we have learned a great deal, but we still face problems with pollution. And when we identify problems, all the rivers, all the lakes are always being tested by state and federal government. And when we find a problem, it becomes, we start passing laws, we start restricting whatever activities causing the pollution, and we try to remediate or fix, reverse that process. But man is not the only thing that causes pollution. Think of all the animals out in the ecosystem, out in the watershed that have to use the water. Think of all the living things that are in the water, from insects to fish, to birds that visit, to deer, to elk, to bears, to all of those different things. And they don't know about pollution. They don't know that they shouldn't be going pee or poop in the water. So there's lots of pollution with surface water. So any surface water basically can make someone sick and could possibly kill you if it isn't treated correctly. So don't ever drink water out of a lake or out of a stream because it's just not safe. And it can be made safe, but it's better than it was, but it's still not good. So what are the problems with surface water? Well, we said that everybody likes to live next to water, and we have our biggest agriculture, forestry in areas where there are those watersheds where we have water on mountains filling up valleys, and we farm in the valleys, we forest in the hills. And we've used for decades fertilizers to get a better yield and better trees, and we use pesticides to protect them. And we always tried to produce pesticides and things like that that stuck around in the environment, so we only had to spray them once. And we found out that's a kind of a negative thing because we found those pesticides in all our surface waters and a lot of fertilizer. But fertilizer is just not the fertilizer that we put in from agriculture or forestry. We find out that half the problem is all the stuff that's coming off city streets and city lawns and off the roadways that were getting dumped into the rivers and streams. We have industrial pollutants, solvents, and oils. If you think about cars running down a road, when it rains, all of those pollutants, all the gases that are stuck to the road wash, go into the stormwater. All that stormwater finds the lowest point, and if we don't treat it, it contaminates our rivers and streams. We have sewage problems because man, overpopulation, and we end up with lots of sewage. And just about everywhere you go has treatment plants where they take that sewage and they try to recycle it, they try to purify it, clean it up so they can release the liquid, the water, back into the water, and then they can use the sewage or the sludge and turn that into fertilizers to help grow crops. And that, believe it or not, is totally organic. And then as we do other things like mining or building roads, anytime we scrape the ground, well, water can flow, pick up all kinds of different heavy metals. It picks up organic matter. Organic means living matter, so like plant leaves, tissues of dead animals, those kind of things. So most of our surface water has a background level of bacteria. And the bacteria, if it isn't happy with the bacteria that's already in our stomachs and our digestive systems, we get very sick and we could actually die from it. So that's why we have to treat water either through a charcoal filter or chlorinate it to get rid of that bacteria. We can always take the water and let gravity take all the solids out, and we can run it through purification systems through dialysis or distillation, those kind of things to get out heavy metals and all those kind of things to turn all our surface water into drinkable water. But again, it takes resources, it takes energy, it costs more money than if we just collected rainwater. But we can't just collect rainwater because it falls, it hits our roof, it gets into our gutter. We still have to filter it, we still have to treat it because it's already touching, the ground. So what I want you to do is I want you to look at this graphic, and this just shows what happens, okay? So we have evaporation, we have something called transpiration, and that's just plants taking water out of the ground, and as they take water out of the ground, they lose water through their leaves, which evaporate and go into the soil. So I not only have soil or surface water evaporating, I actually have plants pulling water out of the ground, and it's evaporating through plants too, okay? So it condenses, forms clouds, comes back as precipitation. Some of that percolates into the soil, goes into the soil, which is available if it's shallow for plants. Otherwise, it can go very deep in the ground and replenish our groundwater. The problem is it takes years. A lot of the surface water, because it wants to go to the lowest spot, is going to find a way to eventually dump down into the sea. And then over the sea, we repeat the process. We evaporate, form clouds, and rain again. And then all these storms are coming in from the ocean because it's cooler here, warmer here, and moves across the land. So what I would like you to do is in a flip grid, I want you to describe the water cycle using that diagram I just provided. So you should be able to split your screen so you can see that and walk us through the process. Now, no one else is going to see your video, only I am going to see it. And I want you to think about what you're going to say and do it in less than 3 minutes because I've set the time limit for 3 minutes, okay? So I look forward to hearing what you have to say. So we'll talk to you soon.